everyone, thank you for viewing my presentation on quantitative assessment of human perivascular adipocyte tissue phenotype. My name is Cathleen Huang, a third-year medical student at University of New England College of Osteopathic Medicine, and I conducted this research at Maine Medical Center Research Institute. To start, we know that adipose tissue is an endocrine organ that secretes adipokines which affect target tissues throughout the body. Perivascular adipose tissue, shortened to PVAT, is continuous with vascular adventitia and regulates vascular tone in a paracrine manner. In healthy individuals, PVAT takes on an anti-inflammatory role by producing factors such as adiponectin that suppress inflammation and promote vasodilation via nitric oxide, decreasing the risk of myocardial infarction. While those with obesity, PVAT changes to cause an inflammatory effect. To understand the cellular basis of PVAT pathology, quantitative measurements to characterize human adipose tissues are necessary to help demonstrate the transformation of PVAT to resemble those of white adipose tissue. Under a light microscope, one can easily observe the qualitative similarities of PVAT to brown adipose tissue to white adipose tissue. However, there has not been a standardized protocol for quantifying PVAT in comparison to brown or white adipose tissue. Our first aim is to establish a protocol for quantifying the adipocytes, average adipocyte size, number of adipocytes per area, and stromal area of PVAT in white adipose tissue in human samples. Our second aim is to determine the precision of the quantification protocol among users. This research aligns with the mission of American Heart Association and osteopathic physicians to build healthier lives. By bettering our understanding of PVAT and its impact on the vascular microenvironment to promote disease, physicians can significantly contribute to the cardiovascular clinical care of individuals with metabolic disease and improve their quality of life. Samples used in this study were part of a larger project approved by the Institutional Review Board of Maine Medical Center, so the identity of the patients were blinded. For this project, I utilized samples from 5 donors undergoing coronary artery bypass graft and mitral valve repair procedures. From each donor, a sample of thoracic PVAT and subcutaneous white adipose tissue, sub-Q, was collected. I used both AdipoSoft from ImageJ and AdipoCount from MATLAB to quantify the samples. I established protocol for each software using the following criteria. 1. Exclude adipocytes less than 500 micrometers squared or greater than 10,000 micrometers squared. Exclude adipocytes along edges of each image, and then for each sample, 4 different areas were taken images of. I then recruited users within the lab to establish precision of the methods. Then we calculated the following: frequency of adipocyte area, average adipocyte size, number of adipocytes per 100,000 micrometers squared, and percent stromal area. Comparison between independent raters' AdipoSoft data was determined by t-test, while independent raters' AdipoCount data was determined by one-way ANOVA, both calculated in Prism. This is the result of using the software AdipoSoft. Top row shows cabbage samples, the bottom row shows VR samples. Let's examine the cabbage samples first. The first graph here demonstrates the average adipocyte size of PVAT are smaller than its counterpart sub-Q. This is expected because PVAT has a protective role similar to brown adipose tissue, which we know is smaller in size compared to white adipose tissue. Additionally, there is no significant difference between the two users' data. The second graph demonstrates there are more number of adipocytes per 100,000 micrometers squared in PVAT than in sub-Q due to the smaller size adipocytes in PVAT. Again, there is no significant difference between the two users' data. The third graph demonstrates more stroma in PVAT than in sub-Q samples. This can be explained by the presence of more connective tissue in PVAT than in sub-Q. Here, too, there is no significant difference between the two users' data. Now let's examine the results of VR samples using the AdipoSoft protocol. VR data reveals the same results as cabbage samples explained previously. Here, too, there is no significant difference between the two users' data. Overall, the consistency is 100% among both users' data. As you can see, I only recruited 2 users because this protocol was very time-consuming and lacked efficiency. I used another software called AdipoCount to quantify adipocytes. AdipoCount was a user-friendly and efficient software. I was more interested in the consistency of this protocol, so I recruited a total of 3 users. In the AdipoCount protocol, a one-way ANOVA test with post-hoc revealed no significant differences between independent raters data and a majority of the samples. However, there were a couple samples that yielded significant differences in the quantification of adipocyte sizes. Overall, consistency for this protocol is around 65%. After bombarding you all with numbers and data, this is my conclusion. Adipocyte size, number, and stromal area were quantified. We found that overall, adipocytes were smaller with more stromal adipose area in PVAC compared to sub-Q. This demonstrates that PVAC exhibits a different phenotype and role from white adipose tissue. With the capability to quantify, more research can be conducted to discover the different paracrine signaling of PVAC. In addition, adipose analysis protocols using AdipoSoft and AdipoCount showed high consistency when utilized with independent users. This is extremely helpful if you have multiple people working on the same set of images to quantify. The limitation of this project is the small number of independent users. However, this is an initial project that can be replicated with more independent raters in the future. This research can create new research opportunities exploring the quantitative differences between adipose tissue in high-fat versus low-fat diets, or healthy PVAT versus diseased PVAT. With a standardized protocol for quantifying human PVAT phenotype, scientists and osteopathic physicians can utilize the established protocol to further investigate the transformative role of PVAT in obesity. Thank you for your time, and I hope this piqued your interest in perivascular adipose tissue. Thank you.